principal axis, this is the concave lens. So see here, a ray of light, this is a ray of light. So this ray of light, and after passing from the concave lens, this ray of light becomes parallel. So if the ray of light becomes parallel, then when you will just extrapolate this line, or you will just draw this line, okay, to the in this direction, then it will look like that this ray of light is going toward the focus. If after refraction the ray of light becomes parallel to the principal axis, okay, then it will look like that this ray of light, initially incident ray, is going towards the focus of the lens. This is the rule number 3rd. A ray of light going towards the focus of a concave lens becomes parallel to its principal axis after refraction through the lens. Got it or not?
Yeah, got it.
Very simple things. So these 3 rules you should know. All of you just copy this first. Write the heading: rules for obtaining images by concave lens. Rule number 1, rule number 2, and rule number 3rd. If any one of you have doubt, then you can ask me. These are very simple rules. When completed this part, you can ask me to scroll down, okay?
Completed, sir.
Okay. So, Ashia completed. Hamna? Martin?
No, I'm doing.
Okay, just write down. Martin done?
Yeah, done, sir.
Okay. Write down this, all of you. Rule number 2. Subhana, are you getting this? Hello, are you getting my voice? Just complete this rule number second. Completed all of you? Manha
Yes, sir.
and Martin?
Yeah, done, sir.
Okay, you are doing. No problem. It's complete. In case of concave lens, when a ray of light is going towards the focus, then that ray of light will become parallel to the principal axis after refraction from the concave lens. And when a ray of light is passing from the center of the, or even optical center, when the ray of light is passing through the optical center of the concave lens, then it will pass straight. Completed? All of you? Abdullah, are you getting my voice?
Yes, sir.
Abdullah, are you writing?
Yes, sir.
And Hamna?
Yes, sir.
Martin completed?
Yeah, completed, sir.
You are doing or just you have completed this thing?
I will draw like that.
Okay, fine, fine. If anyone is writing, then you can tell me, okay? When completed, Martin, please tell me.
Yeah, done, sir.
Done. Okay, now see this. In case of convex lens, there are different positions of object in front of the concave convex lens we have placed, and we got different types of images. But in case of the convex, in case of the concave lens, in case of the concave lens, in front of the lens means here, anywhere you will place the object, always you are going to get virtual erect and diminished image. Diminished means smaller than the object. The image will be smaller than the object. So no matter where you are placing your object in front of the concave lens, you will always get the virtual erect and diminished image. Okay, note down this point also. Note down this point also. So how many positions will be there? One position, you can place the object between the optical center, and the infinity. Okay, and secondly, you can place the object finally at infinity. So there will be two positions of the object. The object can be anywhere between optical center and infinite, and at infinite or infinity. So concave lens will always give the virtual, erect, and diminished image of the object. Done, all of you? Manha
Yes.
and Abdullah,
Done, sir.
Martin,
No.
right. Subhana, completed? Subhana, are you getting my voice? You can write in the chat box if you don't want to speak.
Yeah, done, sir.
Done. So now we will place the object in front of the concave lens, and we will see how the image of that object will be formed. So first case, we will place the object between the optical center and the infinity, and second case, we will place the object at infinity. Formation of images by concave lens. When the object is placed anywhere between optical center and infinity. So I am taking a concave lens. So suppose this is our concave lens. This is our concave lens, and this is the principal axis. This is the principal axis, and this point is the optical center of the lens. So first we will place the object between the optical center and infinite. So anywhere between the optical center and infinite. Suppose I am placing the object here. This is my object. Okay, this is my object. I have placed the object here. So, and we know that then object is a source of light. Object is a source of light. So this object will give the light. This object will give the light. So Manha, tell me, can this pen give the light?
Yes, sir.
How?
Sir, it's reflecting the light which is falling on it.
Okay, good, fine. So this is the object. This object will give the light rays, and those light rays will pass from this lens and the image will be formed. But for the image formation, when we are drawing the image formation for an object, in case of the concave convex lens mirror, so we draw for the two rays only. Okay, if we will draw for the three rays for the object, then the diagram will be complicated. So we will take only two rays from the object, and we will see where these two rays are intersecting. We will get the image simply. So first ray from the object will be like this. This is the first ray from the object. Okay, and this ray is parallel to the principal axis. See this ray. This ray is parallel to the principal axis. So rule number first. See the rule number first. Rule number first. A ray of light parallel to the principal axis. A ray of light parallel to the principal axis will be refracted like this, and this refraction will takes like this. Means when you will produce backward this refracted ray, this ray will meet at focus. Okay, like this. This will be the case. So after refraction, suppose this ray is going like this. Okay. So when you will produce this in the backward direction, so somewhere here this will meet at the focus. Somewhere here this ray will meet. Fine. So first ray from this light source is parallel, or object is parallel to the principal axis, and refraction is taking place. This is the refracted ray. This is the refracted ray, and when I have produced this refracted ray in the backward direction, so this ray is meeting at focus. This ray is meeting at focus. Now another ray from this object will be like this. Will be like this. So another ray from this object is like this. Means this ray of light is passing from the optical center. Rule number second. Ray of light passing from optical center will go straight. See, ray of light passing from optical center will go straight. So both the rays are meeting here. Both the rays are meeting here. This point. So this will be your image. Finally, this will be your image. This. So this is your image. Got it? Manha, Martin, Abdullah, Subhana, Hamna, Arshia.
Yes, sir.
Okay, good.
Yes, sir.
So this is your object, this is your image. So this image is smaller than the object. This image is smaller than the object, means dimness. And are these two rays of light are meeting actually, or just they are appearing to meet at this point?
They are appearing to me.
Why? Because see, this ray, this first ray is going in actual in this direction. I have just produced this ray in the backward direction for the image formation. Okay. In actual, both the rays are not meeting at this point. This is the produced part of this actual ray that is meeting with this ray. So it means that the rays are not actually meeting. The rays are just appearing to meet. The image is virtual. Now see the direction of the arrow. This arrow is in the upward direction and this arrow is in the outward direction. So image is not inverted. Image is erect. So finally we will get the image. All the things will be clear from the diagram. Image will be number one, smaller than object, smaller than object. Number second, virtual and erect, virtual and erect. Number third, the position of the image. Position of the image. So see, the image is in between focus and the optical center. Oh, shit. Just a minute. No, it's okay. This image is in between the focus and the optical center. So position of the image between focus, F means focus, and optical center. Write the optical center as O. F and O. Okay, so see this. This is the practical example you have of this type of image formation. So you have a comb, and you have a concave lens. And see, your object is this comb, and this is the image of the comb. So when you are placing this comb in front of the concave lens, see the image of this comb. Smaller than this original comb. This is the object and this is the image. Image is smaller in this case. Here also the image is smaller. So this is just the interpretation. And this is the, you can say in actual also you will see this. This is the image, this is the object, and this is the lens, this is the comb. Comb is the object here. Okay. All of you just note it down and draw the ray diagram properly. I have told you the rules because I know that these rules will be used in the image formation every time. And I means image. Write down, all of you. And this is a concave lens, we know already. O means optical center, F means focus.
Done, sir.
Done? Okay, good.
Sir, done.
Good.
Sure answer.
Subhana completed.
Yes, sir.
And are you getting this?
Yes, sir.
All of the things, and this is not very complicated. These are the very simple things we are discussing. Yeah. Okay, so Martin,
Yes, sir.
complete. Are you doing or
Yeah,
just
I'm done, sir.
done? Okay, good. Now write down. No need to draw this. I'm removing this just for the understanding. Now write down this part. Then we will discuss the next topic. Do this part.
Yes, sir.
So this is the case when your object is placed between the optical center and the infinity, okay, in front of the concave lens. Now we will place the object and infinity and see where the image will be formed, and the nature, position, and the size of the image we will see. Okay, complete. Now see this part here. You are placing the object. You are placing the object at infinite. When the object is an infinite, your image will be at focus. Your image will be at focus. And this time also you will get the virtual erect and the diminished image, because all the time you will get the virtual erect and the diminished image. And this time you will get highly diminished image. Okay. So write down this also. When the object is at infinite in front of the concave lens, then your image will be virtual, erect, highly diminished. And position of the image will be at focus. The image will form at focus.
Completed, sir.
Okay, fine. So all of you completed this, or anyone left? Martin, have you completed?
Yes, sir. I completed.
Okay, fine. So this is the summary here. You have placed the object at two positions. When your object will be anywhere between optical center and infinite, you will get the image at between optical center and focus, and the image will be diminished and image will be virtual and erect. At infinite, when your object will be your image will be at focus, highly diminished, and virtual and erect. Okay, no need to write this down. But write down the uses of concave lens. Uses of concave lens. So first, concave lens is used in spectacles for correcting the defect vision. Okay, used in spectacles to correct defect of vision. Correct the defect of vision. Second, these concave lens are used in the optical instrument like telescope, microscope. Okay, in these instruments we use these. So used in optical instruments. If you will have the physics in your 12th class, then there is a whole chapter on this optical instrument. There you will study the simple microscope, compound microscope, simple telescope, Galilean telescope. all these things. Okay, write down this. And this part we will discuss in the next chapter, refractive vision. Write down fast. Done? All of you?
Done, sir.
Okay. Should I move?
Yeah, sir.
So I'm moving. If anyone left, then you can tell me. So now, there is one note point. I have already written this. I am again writing this point. So we will write this in the magnification. So the lens formula for the concave lens will remain same. Lens formula for the concave lens will remain same. This is the lens formula: 1 upon V, 1 upon U, 1 upon F. V is the image position or the image distance, you can say. Image distance, or you can say position of image. And always you will measure the position of image with respect to optical center. I have discussed this when we were discussing the sign conventions. Position of image. What is small u? Small u is the distance of object. Okay, object distance. From where? From the optical center. Object distance from the optical center. Image distance from the optical center. Object distance. So this is position of object. What is F? F is the focal length. Focal length. Okay. F is the focal length. What about the magnification? We have already discussed the magnification. Magnification is represented by the small m. So magnification. Magnification small m is given by height of the image produced and height of the object, and this is also given by v divided by u. In case of mirror, here is negative sign, but in case of lens, there is no negative sign here. Here, if you write the mirror formula, then it will become 1 upon v plus 1 upon u is equal to 1 upon f. This is the difference. Height of image, height of object. Height of image, height of object. Okay, write down this fast. I have already written all the thing, but I am just writing this for your revision. and revise again and again the sign convention part. Those who have joined late the classes, they can take the help of my video lectures. Okay.
Done, sir.
Done.
Yeah, done, sir.
I will take very simple numerical on concave lens. Very simple. Remember this formula and this also. Okay. Written, Martin?
Yeah, done,
Done?
sir. Yeah.
You are writing.
No, no, I'm done. I'm done.
You are done. Okay. So now there is one note. If your magnification is greater than zero means positive. Greater than one is greater than zero, one is positive. Minus one is less than zero, that is negative. In this case, you will say if your magnification is positive, you can comment about the nature of the image. The nature of the image will be virtual and erect. Virtual and erect. If your magnification is greater than less than 1, suppose if your magnification, first discuss the negative and positive. If your magnification is less than 0 means minus 1, minus 2 means in negative, then your image will be real and inverted. Okay. If your magnification is less than 1 means 0.5, 0.2, 0.3, 0.4, less than 1. Then your magnification, or you can say your image will be diminished. Your image will be diminished. Diminished means your image will be smaller than object. So magnification less than 1 means height of the image divided by height of the object is less than 1. So from here you can say height of the image is less than height of the object. Height of the image less means the image is smaller than object simply. And if your magnification is greater than 1, if your magnification is greater than 1, your image will be, the size of the image will be larger than object. Larger than object. So you can say height of your image this time will be greater than the height of the object. Okay. Height of the object. Just note down this also. This will be very helpful to you. This part. But you should remember here what is M. M is the magnification. Small m is the magnification. Magnification. All of you in the next class, those who are regular in the classes and those who have late joined, not for those, there will be one test of 15 minutes, okay, of the refraction of light till the image formation, okay, till the image formation by the concave lens. So please try to revise your notes before coming to the next class. 15 minutes of test will be taken. Okay, all of you.
Yes, sir.
And those who are late in the class means not read the topic properly. So you can just tell me. Because when you will give the test, you will identify your mistakes, means what mistakes you are doing. And if you are doing the mistake in the test I am taking in the class, that will be far better when you will do the mistake in your final exam. When you will do the mistake in the final exam means you will not get the sufficient marks, 100 out of 100. Got it, all of you? Manha, Arshia, and all of you?
Yes, sir.
Yes, sir.
Yes, sir.
So write down this. If you are not getting anything, ask me in the class. Okay. Just write down, then we will solve one question. I think in the next class, I will try to finish this chapter.
I have done.
Done. Okay.
Yeah, done, sir.
Done. Subhana completed.
Yes, sir.
So please remember this point, and on this, I will just solve one question. See this question. You can solve this question with the help of this theory. They are saying the magnification produced by the spherical lens. Okay, spherical lens, the lens can be concave, the lens can be convex. The magnification produced by the spherical lens is plus 0.75, plus 0.75. What is the nature of the image? Nature of the lens. Nature of the lens means they are asking what type of lens is this, converging, diverging. So this question you can solve with the help of this, with the help of magnification. Magnification is given to you here. Magnification, first write the value of the magnification and try to identify. Your magnification is given as plus 0.75, 0.75. So what can you say? Your magnification is greater than 0. Your magnification is greater than 0, and your magnification is less than 1. See, your magnification is this 0.75 is less than 1 also, and this magnification is positive also. What will happen when your magnification is positive? The image will be virtual and erect. Image will be virtual and erect. Virtual and erect. And magnification is less than 1 means magnification is less than 1. Image will be smaller than the object. Smaller than the object means image will be diminished. So tell me which type of lens gives this type of image, virtual, erect and diminished for all position of the object. Martin, tell me.
Convex.
Yeah, not the convex, concave. Just I have told. Yeah. So your answer is, you have means calculated the answer. Find the answer. Nature of the image will be virtual and erect. B. Answer B. Nature of the lens will be concave lens. A concave lens is a diverging lens. Diverging, or you can say concave lens. So with the help of magnification, you can solve this question. Just note it down first. Anyone have the doubt in this? Manha, Martin, and Shubhana?
No, sir.
Okay, fine. This is very simple thing when you have understood this thing. Okay, so I am just removing this here from here. Just write down this and remember the thing that those who have joined me from the topic I have started, the refraction of the light, then there will be some test in the next class. Of 15 minutes only. So please don't miss the class. And this test is not for me. This is for you, for the betterment of your understanding. Because I do not have to give the examination. No, I have completed that part. Got it, all of you?
Yes, sir.
Yes, sir.
So we have one class in a week. We have one class in a week, and I am trying to make you understand the things in a simple way as much as possible. Okay. Okay, just write down fast. I am having the next class.
I completed, sir. Can I leave?
Yeah, of course.
Okay. Thank you, sir.
Thank you, sir.
Martin,
No, I'm doing so.
you are writing?
Yeah.